Hi friends, in this video we are solving problem on Jacobian. Given problem is if u is equal to x plus 3y square minus z cube, v is equal to 4x square yz, w is equal to 2z square minus xy. Then evaluate Jacobian of u, v, w with respect to x, y, z. Also at the point 1, -1, 0. Before going to the solution, first we have to know what is the Jacobian. Okay. Now friends, you remember the given functions are u, v, w. U, v, w are in terms of, you see, x, y, z. Here also v is in terms of x, y, z. This w is also x, y, z. So you can say u comma v comma w are functions of x comma y comma z. Sometimes may they will give u is equal to x, even though you can say u is a function of x, y, z. Y quotient 0, z quotient 0, because v and w are functions of x, y, z. That is the reason. Okay. Now, the Jacobian of u comma v comma w with respect to x comma y comma z formula is dou of u comma v comma w with respect to dou of x comma y comma z. Friends, you remember this gives the determinant of u with respect to x. U is the function of x, y, z. So first you have to differentiate u partially with respect to x. Next, u differentiate partially with respect to y. Differentiate u partially with respect to z. Similarly, v is a function of x, y, z. So differentiate v partially with respect to x. Differentiate partially with respect to y and also with respect to z. Similarly, for the w also. So this is the Jacobian of UVW with respect to XYZ formula. Friends, this determinant you may get 0 or non-zero. Okay. If not equal to 0, functionally independent. If it is 0, functionally dependent. Okay. If it is functionally dependent, you will get a relation. Anyhow, now we are finding the Jacobian. Okay. Now, Jacobian of u comma v comma w with respect to x comma y comma z we need to find. So this formula only we have to write. Okay. Consider this as equation number 1. Now friends, what you require? Dou u by dou x, dou u by dou y, dou u by dou z. So similarly, v with respect to x, y, z, w also with respect to x, y, z. So first we need to find out the partial derivatives of u, v, w's. Now I am writing what is u value. U is equal to x plus 3y square minus z cube. Now I want to do u by dou x. Do u by dou x we can also denote with the ux simply. Okay. Now x derivative is 1. What about the 3y square? Is there any x term? No. Is there any x term here? No. So these are independent of x. So this derivative will be 0. While differentiating partially with respect to one variable, we have to treat all other variables as a constant. Now u with respect to y I want. U with respect to y means here it is independent of y. This is also independent of y. So these two derivatives will be 0. And this derivative is y square derivative is 2y. So 3 times of 2 is 6y. Now u partially with respect to z. Here is there any z term? No. Here also no. So these two derivatives will be 0. Now negative sign is there. Z cube derivative is 3z square. These are the values of first order partial derivatives. Right. Next v value. V is equal to, they are given 4x square yz. Now I want to find out vx, vy, vz. So what is the vx here? Differentiation of v partially with respect to x. So this is the product of the term. It is only xyz product is there. So you can say this is containing x term. Okay, here 4yz is a constant. Here you observe friends, this is one term, this is second term, this is third term, but this is only single term. Okay, this is single term, these are three terms. Okay, so here you can say this is the term of x, it containing x, also y and z also. Now I am differentiating this one partially with respect to x. Now 4yz is a constant, so yz first I am writing friends. Now x square derivative is what? 2x. So x square derivative 2x means you will have 2 times of 4 means 8. So 8x y z. That's it. Now v with respect to y. Dou v by dou y is y derivative is 1. Remaining terms what I have? 4x square z is a constant, y derivative is 1. Okay. Now vz. Vz is dou v by dou z. Here z is only z power 1 you have. So z derivative is 1. This is a constant. So 4x square y into 1 is same. Next w term. W is equal to 2z square minus xy. Now differentiate W with respect to x. Then you will have, with respect to x means these are two terms here. So what is the first term containing x or not? No, x term. So independent of x. So you can say this derivative is 0. Next here you have x term. Now x derivative is 1. This is minus y. So minus y into 1 is minus y only. W with respect to y. This is containing two terms. This term is does not containing y. So independent of y. So this derivative will be 0. Here you have a minus x. Now w with respect to z. Is there any z term? Yes, here you have. Z power 2 is there. So z square derivative is 2z. 2 times of 2 is 4z. Minus is there any z term here? No. So independent of z. So you can say this derivative will be 0. Now you have all the values of the determinant. Now you have to substitute these all values in the equation 1. Then you will get, what is ux? Ux is equal to 1. Uy is 6y. Uz is equal to minus 3z square. Okay. Next, vx is nothing but 8xyz. Vy is 4x square z. Vz is 4x square y. Wx is minus y. Wy is minus x. Wz is 4z. Friends, here you observe in the determinant all the values are in terms of x, y, z only. So if they are asking find the Jacobian means directly we have to find the determinant. But they are asking at particularly one point. Which point? At minus 1, minus 1, 0. So we don't want entire Jacobian. We want the Jacobian at this point. If you want to find Jacobian means do directly determinant. But at this point means we have to substitute at x is equal to 1, y is equal to minus 1, z is equal to 0. Now you substitute here. Okay. Now I am substituting x is equal to 1. Here I have 1 only. Y is equal to what I have to substitute? Minus 1. So this will be minus 6 because this is the Jacobian value. Now this is the Jacobian at 1, minus 1, 0. Actually, you here also you can substitute. Ux value is 1. Uy value is at the point. At each point we have to discuss all the values. But I am doing here because you have to know the difference between finding the Jacobian and finding the Jacobian at particularly one point. That is the reason I am doing here only. Okay. Now what is the z value? 0. So 3z square will be. Next here you have a z. So this term will be 0. Here also you have a z. So this term will be 0. Here you have x square y. What is x here? 1. Y is here minus 1. So minus 4 into 1 is minus 4. Next y term is there. Minus y. So minus of minus plus. So this will be plus 1. Now this is minus x. X is 1. So this will be minus. Here it is containing z value. So this will be 0. So friends, you see this is the Jacobian of u comma v comma w with respect to x comma y comma z at any point. This is at only 1 minus 1 0. Now we have to find out this determinant. Now I am doing, you see, 1 into 0 minus 4. Okay. So this will be minus 4. This is minus 6 times of minus means plus 6 times of. This is 0. And what about this? Minus of minus plus 4. So this is minus 4 plus 24. Minus 4 plus 24 means 20. So the Jacobian of u comma v comma w at the point 1 minus 1 0 is. Is it clear, friends? Right. Now I will give one problem for you. Friends, now I am giving a task for you. Please try to solve this problem and choose correct option and mention in the comment box. I will verify if you have done a correct or not. I will reply for you also. Okay. If u is equal to x plus y plus z, uv is equal to y plus z, uvw is equal to z, then find Jacobian of x comma y comma z with respect to u comma v comma w. Choose the correct answer. Okay. Now I am giving a hint for you. Friends, you see, if you want to do the Jacobian with respect to x, y, z, Jacobian of x, y, z with respect to u, v, w, first we have to change x is a function of u, v, w. Similarly, y, z also. Here you observe u is a function of x, y, z. But I want x is in terms of u, v, w. So you have to rearrange. Try to rearrange. Any hint they are given, you see. u, v is equal to y plus z. So y plus z here you have. So y plus z is equal to u, v if you written. Then u is equal to x plus u, v. You can write x is in terms of u, v. Here you have a z. Z is equal to u, v, w. So similarly, y also, this z value you can substitute here. You can get the y value. So in this case, x, y, z all are in terms of u, v, w. Now you can do directly Jacobian. Okay, friends? Wish you all the best. Thank you.